All right, MEGN 300, we're going to be talking about how to set up your VI for the audio capture lab today. So for this first activity where you get to use the DAC for the first time, I'm going to take you step by step through how to set up the DAC in LabView and how to get data off of the DAC. You'll get a chance to try this out when you come to the lab and collect data for the first time. And then after that, we're going to give you a little more freedom to figure this out on your own. But we're going to hold your hand for this first time. So let's go ahead and get started. So in this lab, what we're trying to do is we are going to connect our audio cable to the DAC, and we'll collect the analog voltage signal that normally goes to your headphones that makes sound that you listen to when you play music. We're going to collect that, record it with LabView, and save it as a .wav file that we can then play back on the workstation in the lab. So what we need to do here is sort of block out how our program is going to work. And this LabView VI is going to be a little more complicated than what we've done in the past, so we want to think about how we're going to plan out our block diagram so that it's neat and we can follow what's going on. So good programming practice in LabView is to generally start over here on the left-hand side and then work our way right. So what needs to happen first in the program is going to happen over here on the left. Then we have sort of our main loop that the VI runs continuously until we tell it to stop. And then we have our final actions over here on the right. So the first thing that we're going to have to do is we're going to have to set up the DAC. So we'll do things like set our sample rate and which channels we'll be capturing over here. And then we're going to have a loop that continuously acquires the audio signals, right? And when we hit stop on our VI, what we want it to do is we want to save a .wav file so that we can play back our sound. So that's the general gist of what's going to be happening in here. So let's go ahead and get started by adding our DAC to this VI. So we have provided you with some DAC VIs that are sort of a simplified way to interface to the DAC. There's some built-in functions that you could also use, but for this class, what we're going to focus on is just a straightforward, just kind of limits the options that you have available to you, so that it's just focused on what we're working with in this class. So the way we can select those VIs is if you right-click, and we're going to have to scroll down here to this option, select a VI. And you'll need to navigate to where these are saved. Now, in the lab, it's very important that all of the VIs that we work with are saved in a local folder. So when you go there, you can select local disk C, and you should see a folder on C that's labeled Scratch. You want to go in there and you want to make sure that you save those VIs from Canvas on your Scratch drive. When you go to Scratch, you can make a folder with your initials, and nobody can access that folder except for you when you're logged into that local machine. And you can save all your folders in here. So I've gone ahead and I've made a DAC VIs folder on my Scratch drive where I can save those, and those VIs are going to be saved locally on that machine. So important things to note. Why are we saving in this Scratch drive? So LabView behind the scenes is constantly reading and writing to files. So basically every time you change something in LabView, it's essentially recompiling the program. And that requires a lot of reading and writing from these background files that are part of the VI. If you save your VI on a network drive, so things like the desktop on the lab machines or your Z drive, there's enough latency or lag between your desktop and that network drive that what happens is LabView gets halfway through writing to one of these background files, and then you change something and it interrupts that and it corrupts the VI, and then you lose all of your work. So it's very, very important that you always save on the Scratch drive. You can't access the Scratch drive anywhere except for when you're physically logged in standing at the machine in the lab. So at the end of lab, what we suggest you do is close out of everything and then save a copy of your VI somewhere else where you can access it, be it Dropbox, emailing it to yourself, your network drive, whatever you guys like to use. Do that after you're done and you've closed out of LabView for the day. That is the best way to make your data accessible without also running the risk of corrupting your VI. So But anyhow, we've got our DAC VIs here. I'm going to select this analog acquisition VI and hit OK. And you may get a warning. That is OK. And we're going to drop that down into our block diagram. All right, so this VI right here is what's going to physically talk to the DAC for us. It has a bunch of different options that we can set here of our different acquisition modes. So if you click this drop-down menu, we can select what we want to do. In our case, we have 2 audio signals that we want to read in. So we need multiple channels, and we don't want to take just a single data point at a time. Doing that would cause too much latency with our loop would have to run really, really fast to keep up with the DAC at the sample rates that we're going to be using, which would just cause your VI to crash. So the option we'll be using today will be multiple channels, multiple samples. Right? So what this means is we can set up multiple channels, and what's going to happen is the DAC is going to collect a bunch of data points really quickly, and it buffers them on the DAC's internal memory, and then when it reaches a certain number of samples, it will send that data over to LabView as a big array, and then LabView can process that. All right, and that works really well because the DAC is very, very fast. It can buffer those samples really quickly, and then LabView can take a little bit more time to process this array of data rather than having to process every single data point as it comes in and is collected by the DAC. So that's the option that we'll use here. Over here on the left-hand side are our variables to set this up. So we have our channels. So this is where we tell LabView which physical channels, so like what plugs we're plugged into, so that it knows which channels to read on the DAC. The number of samples, so how big of an array do we want to collect before we send data over to the LabView loop, and the rate, so what's the sample rate that we'll be collecting data at. So let's go ahead and set these up. So the easiest way to do this is you right-click on the terminal that we want to make here, and we're going to do create constant. And that's going to generate a constant that's the correct data type for this particular input right here. All right, so you notice that we got an array. Whoop. We've been given an array. Drag it out a little ways. There we go. That has these drop-down menus inside of it where we can select the physical channels. So element 0 is the first element in that array. If I mouse over this to where I get the little finger, I can click on that and it will list out the different channels that I have available to me. So I'm doing this on my laptop, so my channels are going to look a little bit different than yours. What you guys are looking for is a channel it's probably going to say PCI 6221 and then the different channel numbers, and you have your analog input and then the number associated with that. So you'll want to look for channels that say that. I have a little bit different setup here, so I'm using a MyDAC, so mine say a MyDAC, and I actually have an audio jack where I can select these two, so I'll select the correct channels for my particular application, but you're going to be looking for PCI 6221, or on a few of the machines, there's a DAC card called PCI MIO, and then a bunch of numbers and letters. Either of those options are going to be correct. If you see anything that starts with dev, like this right here, that's a simulated DAC card, so it's not a real physical DAC card, so just don't select those options. So PCI 6221 is about what 90% of you guys are going to see when you come into the lab. So I'll select that. To get to the next channel, you can use the up arrow here to go to element 1 in the array, which will be the next channel that we're using. So I'll select audio right with that one. All right. And then we have our number of samples. So in the prompt, it tells us to create a constant so that we collect 5,000 data points at a time. So you just type that into the constant. Drag that constant over here, try and keep this neat. And then our sample rate, we'll create another constant. And we are looking for a sample rate of 50,000 hertz. So we'll just type in 50,000. All right. And it's a good idea to add some comments at this point because this could get messy a little bit later on. So we can say what each of these constants are. number of samples, and sample rate in hertz. There we go. All right, so now we have our DAC set up and configured. So our data is going to come out here as an array of the waveform data type. So that's where we'll be accessing that. But first, remember, we want a loop because we want this to acquire data more than one time, right? So we want to basically start running the VI. It collects data, breeding in these arrays or as waveform variables, and building those up over time until we hit stop, and then we're going to save the file after that point. So we're going to need a while loop in this situation. So we'll go to structures, grab a while loop. We'll draw a nice size box here. And that is our while loop. And our while loop always needs a stop condition. So I'm going to right click, create control to get a stop button on my front panel. All right. So here's our data coming in as an array of waveforms. The easiest way to deal with this is to split the audio left and audio right channels apart so that you just have a single waveform. And then you can use your waveform data type manipulation tools like the append waveform block on each channel independently. So the way we can break that array up is to use the index array block. So come out here, go to array, index array, and I'm going to drop that down and connect my array of waveforms to there. And this is one of these boxes where we can click and drag to get multiple channels out. So I dragged, so I have two outputs here. So this is going to give me element 0 and element 1, which would be my audio left and audio right channels. All right. So each of those, we're going to need to take whatever data is coming out of the DAC, append it to the end of the data that's already been collected, and then repeat that process until we hit the stop button. Okay, so what we need to do is we need to have access to the data that's already been collected. So we need someplace to store the data that we collect on this loop iteration and pass it to the next loop iteration. In LabView, we do that with a shift register. So to get the shift register, you can go to either side of the loop right here, just the left or the right hand side, one of those vertical lines, and right click. And we're going to say add shift register. Okay, and we're going to need one shift register for each channel. So I'm going to add another shift register. So let's again right click on the side, add shift register. Okay, and we're going to need the append waveform block so that we can keep tacking on the new data as it's collected to the end of the data that's already been collected. So that's under waveform, analog waveform, append waveforms. We'll need two of those blocks, so you can copy and paste that. You can also control click and drag, and that gives you another copy of that append waveform block. All right. So here's our two channels. So what we want to do is this is the new data coming out of the DAC, so the most recent data. We want to take that and we want to add it to the end of the data that's already been collected. So this is going to come on here. We're going to attach this to waveform B because that adds our new data to the end of the existing waveform. Otherwise, it would keep adding the new data to the front of that waveform and our song wouldn't play correctly. It would sound really funky because it would be little chunks of the song sort of playing backwards. All right, and we're going to take this waveform out. So this waveform out will be the old waveform with the new waveforms tacked onto the end of it. And we want to take that and put it into the right-hand shift register so this appended waveform is available to us on the next loop iteration. Now we can take the left-hand shift register, which will be all the information from the previous loop iteration, and that's going to become waveform A. Right, so we take the old data, add the new data onto the end of it, and save that in the shift register, and we keep repeating that process until we hit the stop button. We just need to do the same exact thing with our second audio channel here, the audio right. So I'm going to connect the element coming out of the array to waveform B. Waveform out goes to the shift register, and the shift register goes to waveform A. All right, you can see things are starting to overlap a little bit here. You can always take this shift register and move it up and down. Just click and drag. so that you can keep things neat while we're working here. All right. So the other thing we need to do with our shift register is we need to initialize that shift register. By default, if we just leave it like this, that shift register is a location in memory. And when we run the VI, we're not clearing out the memory. So just whatever's been stored in there is still going to be in there every time we hit run on the VI. So we would always have everything that's happened since we opened LabView and however many times we've run this VI, we would have all that audio saved in the shift register. What we'd like to do is start with an empty waveform so that we just get a new recording every time we hit run on this VI. So the easiest way to do that is to come to our shift register, right click, create constant, and this is a waveform variable. Here, if we can get it to select the whole thing, just that. We can drag that out of the way, and this is going to be connected. It is connected to our shift register. If we drag the wire over, we can actually see that clearly. And so here's what's inside of our waveform data type. So we've got the start time, right, when we start recording. This second constant right here, that's DT in seconds. And then here's our empty array of Y values. So that's what's contained inside of the waveform data type. Now, right off the bat here, we've got a problem because our DT is set to 1 second, but our sample rate is set to 50,000 hertz. So that's not matching, right? So to set this to the correct value, we need to do 1 over 50,000 to get our correct value of DT, which should be 2e to the negative 5 seconds. So that's our correct DT value. If you don't change that, what happens is you record sound for a couple of seconds and then you try and play back the WAV file and it'll be maybe 10 hours long with absolutely no sound in it because it's spacing out all the data samples that we took by 1 second individually. So you end up with a way too long audio file and everything is so low frequency that's below human hearing. So we need to initialize both shift registers this way. You can go through creating a constant here and changing it again. You can also just take this wire and connect it to the second shift register so this data goes into both the shift registers. All right. It's coming together. So we've got our shift registers initialized. We've got our waveforms getting appended. So let's go ahead and add some comments. Right, that's the step that's happening there. Break apart our left and right channels. All right, so when we hit stop on the VI, on the front panel, after this is running, our audio left and audio right recordings of the whole time the VI was running are going to be stored in these two shift registers here, and we can access them on the right-hand side to save them as a WAV file. So in the instructions, it tells you to use this SoundWrite file simple VI, so we can go ahead and get that so that we can configure it and get it to save our WAV file. So you can go through searching through the graphics and sound palette. If you go to graphics, sound, files, it's going to be this simple right here. But say you forget that, always remember you can come up here and you can search. And you should find sound file right simple. Double click that, it'll take you to exactly where it is in the palette, and we can drop that down. And close our menu. So this is what's going to be writing our WAV file. And anytime you get an unfamiliar VI like this, it can be helpful to hit Control-H to bring up the menu and mouse over it, and it'll tell you exactly what you need to know to hook this up. So in this case, we need the path, which is basically the file name and location where we want to save the WAV file. There's our data that comes in, and that's going to be a 1D array of waveforms, right? So we need to build our single waveforms back into an array with the audio left and audio right channels so that we set that up. These other input options are going to be optional. So these are the two that we really need to do here. All right. So why don't we handle figuring out our file name first? So we need some way of deciding where we're going to save the WAV file. So one way we could do that is to have a file dialog. So if you go to File I/O and Advanced File Functions, there's this file dialog box. So if we grab that and drop it down here, it's going to ask you how you want it to work. So we only want to select one file. We're selecting a file, not a folder, and it can be either new, so we can create the file, or an existing file. We'll hit OK. And they're going to select a path, right? So the path, again, is just the location and the file name put together. Now we are going to connect that to the path here. So now when we run this VI, there's going to be a dialog box that pops up, and it will ask them to save the file in a location. Now, right now, this file dialog box is not dependent on anything. So as soon as we hit run, it's going to have all the information that it needs to run. So it's going to pop up immediately as you hit the run button. That may not be the behavior that you really want. So one way you can force this to not pop up until we hit the stop button on the front panel and we're ready to actually save the file is we can create a dependency of this file dialog box on the loop somehow, so that this doesn't have all the information it needs to run until the loop is done running. A great way to do this is with the error wire. So you see this has an error in, and a lot of LabView VIs have an error terminal on them also. This one has one also here, error in, and your DAC has an error out. So we can take the error out, connect it to error in, and now this will not pop up until we hit the stop button on the VI, right? So that's a good way to control the order that things happen in your LabView VI. All right, so we're finally ready to add in our data here. So we can take our data. We need to take our two waveforms that we've got saved, and we need to build them into an array so that we can send in a 1D array of waveforms into the data here. So to build an array, we go to the array palette, and we grab the build array block from right here. We need two inputs, so we can drag down, so we have two inputs, and we have our array out. We'll take our first audio channel, connect it, connect our second audio channel. Now we have an array of waveforms that we can connect to data, and we have the basic bones of our program here, right? So here we're recombining audio left and right. We're going to save our WAV file here. All right, and we're selecting our file selecting our file. One note here, you do need to include the extension. So when you save your file, make sure at the end of the file name you actually type .wav. That will let Windows know that that's a sound file that you can play. If you forget to do that, it's okay. You can change the file later on in Windows itself, and it'll still work fine, but you won't be able to play the file until you have the correct extension on the end of the file there. All right, that is the basic bones of the audio capture lab. I'm going to let you guys figure out how to include the graphs that it asks for on the front panel, and we will be in the lab and we'll help you get this fired up so that you can see how this all works. All right, good luck, guys.